Okay, so we're ready to go. We'll do a quick run through. Here we have our battery voltage on this meter. This one is going to show us the current into the motor. This meter here is going to show us the current out of the motor and into our load. This one here is going to show us the voltage across our output cap. And our lux meter here is going to show us the luminums. We're set on 10 times at the moment. The reason we're doing this is because back here you'll see a wire here. It's connected to my power supply, which I have preset to somewhere around where we're going to need it. And we're simply going to hook the light bulb up to our DC power supply via our current meter, get the current and the voltage close as we can to the same as the output from our engine was coming from, and hopefully our luminums reading will be the same as well. The scope I have at the moment hooked up across the cap. I'll disconnect that as soon as I show you this. It's just to show us the noise across the cap when the motor's running, just to make sure that that is stable enough for our meters to be doing a pretty good job at reading correctly. 2 millivolts per division, and you will see a lot of noise coming from the coils and the wires and all that. Just a bit of crap that's floating around the air. Not a lot to worry about. Okay, so let's get on with it. We're going to start our motor first. And let it settle. Peel a bit of surface charge off the battery. Okay, so they're about 12.4 volts, 2.08 amps. Down as the motor's warming up. The bearings are getting warmer, a little bit freer. Haven't cleaned them, done anything like that. They're just greased as they were. The only thing I've done to that motor so far is remove some of the spring tension on the brushes. So it's pretty safe to say we're around 12.35 volts at 2 amps is our input. Of course nothing on our output yet, which we're about to do. Okay, now we have 12.42 volts, 43. It's going up because of course now we're drawing less current off the battery. The battery is recovering a little, but let us say somewhere around there pretty close. So 12.44 volts, 750 milliamps on the input to our load apparently. Have 1.583 amps at 9.37 volts, and that is the scope tray set on AC coupling, 2 millivolts per division across our cap. And I will take a screenshot of that and post it along with this video. And although it looks terrible, we are at 2 millivolts per division. And while we're at it, we can also check here our voltage. So 9.6 volts RMS, and our meter's saying 9.25. So depending on which one you want to go off, we'll go with the lowest voltage. We'll say 9.23 volts, 1.567. I'm then going to remove my scope so as we know that that is not interfering with anything. You can see nothing much changed. Our aluminium's meter is on 145 and that's 10x. So it'll be 1,450. So we need to get that reading the same as what we have here at the moment on our DC current. So 9.2 volts at 1.56 amps should give us around 145. We'll turn that mess off. So all we simply have to do is take our amp meter on, put on the positive side, then we will have to get a clip lead to go on the negative side here. Like so. And we'll turn our power supply on. 9.07 volts, 1.56, so our current's pretty close. The voltage is a little low, so we'll turn up our voltage a little bit. Okay, maybe a little high. That's going to be pretty close now. 9.2627, 1.57, and we have 149. So the current's a little bit higher, the voltage a little bit higher too, I think, from memory. But as you can see, I can wind that down a little bit more. See how close we can get it to spot on. And a tad more. Okay. I don't quite remember what the voltage was, but the current was 1.5 something. 146. So we're pretty close from what we can make out here. And that's running off my power supply. Current is limited at 1.5 amps, somewhere around there. We're not using that much. Well, we are. Actually, no, that is actually reading what we're using. 9.93 volts there, 9.21. Our scope and power supply saying this is reading a little low. It's just an El Cheapo meter. But failing that, the error remains the same in this test as it did on the output test of our generator there. So keeping everything even, we are pretty close, which tells us our meters must be reading right, but there are other things that are telling us our meters are reading wrong. So that's where we are up to date, and I think we're going to have a little closer look at what's going on here. I'm pretty confident my meters are very accurate, and as you can see we don't have much noise across our output, and I've already put the scope shots of the input up on the forums, and it's not too bad when we consider that we're all looking at 2 millivolts per division. So that's where we're at. We'll see how we go with this. I guess the next objective is to loop the output back to our battery, and we're actually working on that at the moment, because if I go straight from the output to the input, the motor stalls. It's like it's shorting it or something. So we're going to go via way of DC to DC converter and see if we can sort it out that way. But this is where we're at the moment, and I think we're pretty close to having accurate input and output measurements. Alright guys, I'll get this up and use Contour over and see what you reckon. Cheers.